In this video, we will be talking about rational and radical expressions. First, we're asked to simplify the square root of 4a squared over 9b to the fourth. And as you get more and more practice with these will become easier, and you can be able to see them right away with perfect squares inside of terms. But when you're, if you're kind of stuck or you can't figure it out, a really good way to figure these out is to do a factor tree. So let's do first a factor tree for our numerator. We have 4a squared. And when you're doing a factor tree where you have constants and variables together, the very first way I like to factor is to split up the constants and the variables. So that gives us 4 and a squared. And I do that just because it kind of helps when you're trying to figure out the end product, just to not have letters and numbers all mixed up together. So if we continue factoring, 4 factors into 2 and 2, and a squared factors into a and a. And since when we're looking to solve or to simplify radicals, we need to look for squared terms, because a term squared, square rooted is the term itself. So basically, if we put that, the square root of a squared is just a, and that's kind of the general form of these things. So here we have the numerator becomes, I'll write it out here, 2 squared times a squared. And if we look at the denominator, we have 9b to the fourth, which splitting up the constants and the variable, we get 9 times b to the fourth. The 9 is 3 times 3. b to the fourth is b squared times b squared, which means down here we have 3 squared times b squared, and then the whole thing squared. And since, like I said, a square root of a term squared is just the term itself, we can see that this is going to be the square root of 2 squared is just 2, the square root of a squared is just a, the square root of 3 squared is just 3, and the square root of b squared squared again is just b squared. So when we simplify it and get rid of those multiplication signs, you just get 2a over 3b squared. That's how you do those kinds of problems. Let's do another one. We're asked to simplify the square root of 16x squared plus 8x plus 1 all over 32x squared. So this is a little bit more complicated, because instead of having everything multiplied together, we have more than one term that are in fact added together, so we have to be a little bit more careful. Again, we're going to be looking at the numerator and the denominator, and probably using a factor tree. However, we need to first kind of look and see, okay, we have a 16x squared plus an 8x plus a 1, and that looks like it could be a quadratic expression. And if we remember from a perfect square trinomial, that states that something in the form a squared plus, a squared plus 2ab plus b squared simplifies down into a plus b squared. For us, a would be just the square root of 16x squared, which is going to be 4x. b is going to equal the square root of 1, which is just 1. And 2ab is going to be 2 times 1 times 4x, which is 8x. So if you stick that into the formula, you see we do get 16x squared plus 8x, which is 2ab, plus 1. Which means this is in fact a perfect square trinomial, which means that this can factor into the following. We can factor into 4x plus 1 quantity squared from the a plus b quantity squared. And now we can look at the denominator. We have 32x squared, breaking up the 32 and the x squared. 32 we know is going to be 4 times 8, and x squared is x and x. 4 we know is 2 and 2, 8 is 2 and 2 and 4, and 4 again is 2 and 2. So we're looking for pairs. Here we have a pair, here we have a pair, here we have a pair with a lone 2. And that basically just means we have 2 squared times 2 times 2 squared times x squared on the bottom. And if we double check, that's 2, 4, 8, and then 16, and then 32 x squared. So it does check out. Using what we had above, where we have the square root of a term squared, it's just the term itself, we can take that up here and see that this is just 4x plus 1 over, now we have a squared term, so 2, times another squared term, which is 2, and a third squared term, which is x, And then we have the leftover 2, so this is times square root 2, which when we simplify that down gives us 4x plus 1 over 2 4x times square root of 2, which is going to be our final answer for this kind of thing. If you wanted to, it depends on the instructions, but you can rationalize this, which is a lot of times what we want to do. And all that rationalizing means is that we have no square roots on the bottom. And all we have to do to change that is to basically cleverly multiply by 1. If we're given 4x plus 1 over 4x square root 2, we can get rid of the square root 2 by multiplying by square root 2 over square root 2, which is just 1. But when we do that, you see that we get 4 square root 2 times x plus square root 2. I'll put this in parentheses. And then the 4x square root 2 is 4x times 2, because square root 2 times square root 2 is 2, which means I'll put 4x square root 2, just rearranging it a little bit so it's easier to see, plus root 2 all over 8x. And that's going to be another completely acceptable final answer. Something that you're just going to check with either your teacher or with the instructions to see if they want you to rationalize the expression or not. Lastly, we're asked to know when to look for extraneous roots and how to identify them. And an extraneous root is a solution for a variable that you get that, while you mathematically get it, is not a correct solution because it's a solution that we get when we lose information from squaring. So we lose information about a sign because we square it. So even though you get negative 1 or positive 1, it depends on the previous problem. So you have to just go back and check it to make sure it makes sense. So the first one, or this one, the only one, we have solve the square root of x plus 3 equals 2x, and then identify any extraneous roots. First thing we're going to want to do, we can't really do anything with square roots over them because it's kind of like apples and oranges. You can't really combine them. However, we can square both sides, which will get rid of the square root. So the square root of x plus 3 quantity squared is just going to be x plus 3. Again, using this idea up on the top, the square root of a term squared is the term. And 2x squared is going to be, well, I'll write that first. And that just gives us 4x squared. We can see that this kind of is quadratic, which means we need to bring all of the terms to one side and set it equal to 0. We can do that by subtracting x plus 3 on both sides, which gives us 4x squared minus x minus 3 equals 0. And this becomes a minus here because we just got rid of the parentheses. Now we can just look at these and look at the factors. The factors of 4 are 1 and 4, 2 and 2. Factors of 3 are just 1 and 3. With a little bit of practice and a little bit of just kind of trying things out, we can see that this will give us a factor of x minus 1 times 4x plus 3. And we can double check that with FOIL. X times 4x is 4x squared, x times 3x, minus 1 times 4x, which is minus 1x, and then minus 3x, so it does check out. And when we have this, we see that x minus 1 times 4x plus 3 is going to be equal to 0. Setting each term equal to 0 is how we're going to solve for the x, just like always with factoring. And then we get our solutions, x equals 1 and x equals negative 3 over 4, which comes from just moving this 3 over here and then dividing by 4. Now we have two solutions here, but we need to check them. And we do that by plugging that into the original equation, and seeing if it holds true. So first, if x equals 1, we see we get the square root of 1 plus 3 equals 2 times 1, which says the square root of 4 equals 2, which it does. Next, we're asked to check if x equals negative 3 over 4. That's negative 3 over 4 plus 3 equals 2 times negative 3 over 4. But already we can see that the left-hand side is going to be positive and the right-hand side is going to be negative, which means this is no longer true because a negative never equals its positive. So that means this is extraneous, which means our final answer is simply x equals 1.